So I'm Brian Hellman. I oversee the U.S. operations here. I represent LINBIT. And today we're joined by Thomas Harris from Nomad, and he's going to give us an overview of how Nomad works with the CSI driver and LinStore.
Cool.
You want to go ahead, Thomas?
Yeah. So thanks for the introduction. I'll start sharing my screen. Oh. Yeah, so as Brian mentioned, so I'm Tom Harris. I'm a solutions engineer for HashiCorp. I've been working for HashiCorp for just over 2 years now. So obviously been quite a lot of change in that time. HashiCorp is a fast moving company. Just a little about who we are. So HashiCorp as a suite of tools, all available as open source. You know, it's really sort of at the core of our values that we have open source tooling, and most of these have an enterprise flavor with support and extra features and functionalities that are important to enterprises. And one of the main principles that these tools have is providing a consistent workflow for provisioning, for security, and for networking. So ensuring that we can get your app up and running in a secure and consistent way, ultimately. So we're going to be talking about Nomad today. We're going to give sort of a bit of a dive into Nomad. And first off, let's talk about why Nomad is an orchestrator, to be clear, but why do we even need an orchestrator? Okay, so predominantly this need for orchestration has come around with the move to containers, the move to clouds, and the move from an application and all its dependent components deployed on a single VM in a monolithic sort of configuration. So breaking up that application into a more of a microservice architecture, and sort of, in general, leveraging containers to do that. It becomes sort of difficult, if not impossible, to ensure all those services that are deployed in containers, because there'll be many more of them now, highly available, scalable, if you're just using sort of Docker CLI commands at the command line, right? And this shift to using multiple cloud providers also means that there's different tooling used across those cloud providers, and really no single control plane and visibility into the application landscape. And also some applications are impossible or very difficult, or do not make sense to containerize as well. Okay, so it starts us getting thinking about how do we treat those applications in a consistent way as we're treating our microservice applications. So this is why why Nomad, because one of the guiding principles of Nomad is to ensure that applications can be orchestrated in whatever format that they are run, ultimately. So yes, we cater for Docker containers, sort of Podman, etc. The containerization world, but we can also orchestrate sort of binaries. Even if they're on Linux or if they're on Windows. We can orchestrate even sort of Mac OS applications as well. So it gives you this sort of flexibility, ensuring a consistent workflow. And really the goal is to become this single orchestrator for all cloud providers and on-premise as well, having that single consistent workflow across those providers. HashiCorp, all of HashiCorp's products generally have a sort of a broad system of ecosystem integrations, and Nomad is no different. We'll probably talk about a few of these different integrations as we go through this deck, basically. And there's some very well-known public users of Nomad as well. I think Roblox is probably the most famous, but there's quite a few more out there. Or Roblox are probably the most prolific, I would say. So let's talk about how we, what we need to do to deploy an application, and then what teams are involved in deploying that application, and hopefully how Nomad can help that. So we've got sort of, really two distinct teams that are involved in deploying applications into production systems, and they have distinct interests. So we've got developers who care about the application lifecycle, pushing out new code changes, either that's features, bug fixes, scaling out different parts of the application as needs dictate. And then we've got operators, and their interests are, in the underlying operating system, ensuring that it's secure, ensuring it's patched, ensuring that there are enough resources to run the applications. And developers and operators sort of have to have this coordination in some way to ensure both their interests are met. And this is often done through, or has historically been done through ticket-based systems. So with Nomad, as a developer, and I need to deploy an application, I submit a job file, which will go into sort of the anatomy of a job file a bit deeper later. And then Nomad is in charge of ensuring that that job is placed somewhere in the cluster that has the correct resources to actually, service that application. If the developer needs to update the deployment, they just submit that job again, to resubmit that job to the Nomad API. And as an operator, I don't have to get involved in this process, right? I'm just maintaining the platform, ensuring the integrity of the platform, the security of the platform. And I can let my colleagues who are developers continue to develop the application in a friction-free way. And some of the sort of operational benefits that organizations are seeing with this is, with Nomad in general, is that it can really reduce the total cost of ownership of the underlying resources that the application is deployed on. Okay, so we've got quite smart algorithms that decide where a job should be placed. So something that we call bin packing, ensuring that as many sort of jobs are on a machine as possible, and we've still obviously enough resources to run those jobs, and then changing placement as needs dictate, right? And this is very difficult to do in a manual fashion, and to get higher utilization out of your underlying resources. And I think most sort of VM resources are probably only sort of between like sort of 2 to 5% actually utilized, so we can get, ensure that your cloud costs are ultimately cheaper as well with this. So it's a nice byproduct of Nomad. Just to call out here as well, we also have a spread scheduling, a logarithm as well, so we can spread it across the cluster. If you've got those really sort of high performance applications that need that ultimately. Nomad is run as a sort of just a single binary, as with most of HashiCorp products. So it can run in server mode or client mode, and clients will actually sort of run the jobs. Server is ultimately the overarching API, and responsible for configuration and placement of those jobs onto the clients. So what that means is we can even run this on our laptop, and many do for development. Okay, so I can run a Nomad agent in development mode, and then submit jobs to the same API that I would be in production. Okay, so there's no sort of Nomad ADM tool or anything needed to spin up a cluster. It's very easy to spin up, and we've got sort of I'll talk about console for service discovery, and actually sort of cluster federation as well. Oh, sorry. So in more of a production environment, in a single region, you'd have Nomad servers split across availability zones, and then Nomad clients within those availability zones actually doing sort of hosting the jobs. So obviously it's redundancy within a single region. We've also got this concept of federation as well. Okay, so if I want clusters in different regions for different purposes, for availability of applications, to put applications closer to the consumers, I could deploy clusters in different regions, but actually federate those clusters. And what that means is we've got this sort of visibility of all of the clusters that are, that we're operating, and we can actually submit a job to sort of a unified Nomad API that we can then deploy to those different clusters. And federation in other orchestrators, mentioning no names, has often been very difficult and has not sort of really reached production levels. But Nomad has this idea of what you can see on screen there, a Nomad server join, and you can, as long as you've got the correct policies in place, you can join those two servers, right, and they're networking in place to do that. You can just join those two servers, and it becomes multiple clusters managed, from a single control plane. Okay, and to be clear, these can span different cloud providers and also on premise as well. Because the fact that Nomad is just a single binary that's running on a Linux machine gives it that ability to have that sort of flexibility across different providers. And at the heart of sort of everything that HashiCorp do really is this idea of as code, infrastructure as code, application deployment as code, and the job files that a developer would submit to the Nomad API are written in HCL, which is HashiCorp configuration language. So if you're familiar with Terraform, I'm sure there are people in this call who use Terraform. You have exactly the same sort of format of writing your sort of declarative syntax ultimately. We've got these, you've got the task, or when you're actually writing a job file, you've got the task, which is sort of the atomic unit of a Nomad job file. And then we have groups of tasks, and then the overall job that defines the sort of the application deployment. So it's quite just an intuitive way of writing sort of a deployment rule for an application. And then when I've mentioned about sort of that flexibility to not only deploy containerized or orchestrate containerized applications, but also non-containerized applications, this really comes down to the idea of having these different task drivers. So you can see this example is the Docker task driver, but we can select different task drivers for different types of images or binaries. The nice concept of when application is needs dependencies on other applications, we can put this lifecycle hook in there to define which order the applications come up in or the services come up in. Nomad is sometimes sort of as primary as a batch scheduler. Just when there's this sort of impression out there that it's mainly a first-class sort of batch scheduler. That's absolutely not the case. So Nomad does batch scheduling very well, but it can also run sort of long-running jobs in a service fashion, okay, rather than batch as well. With many sort of or a handful of update strategies. If I push out a new version of my application, I just don't want to just kill the current version. I want to sort of a strategy to actually update correctly. So we could do rolling updates, blue-green deployments, canaries. Okay. So from the example of a rolling update, we can do that in a zero downtime fashion. Nomad sort of destroying one of the first allocations. That's how we describe sort of job placements within Nomad. It destroys the first allocation, creates the second, and then sort of rolls through them until we have sort of a full healthy set of our V2 version of our application. We also integrate with or support CNI. Okay, so if you're using things like Calico, WeaveNet today, then you can sort of port some of that logic over into Nomad. Then we've got this idea of sort of multi-interface networking as well. So we can use the host, different host connections on the machine, and then route our application traffic through different interfaces as needed. There's a lot of focus today on applications being sort of stateless and ephemeral. There's absolutely the need to have state when running applications such as databases. It's a given that we need state within the cluster. So Nomad has the concept of being able to run those stateful applications, obviously, and the sort of the choice of doing this nowadays is through integration with the container storage interface. So that's what LinStore exposes the container storage interface through their driver, which the LINBIT guys will talk about a lot more later on. So you can, what we do is we can just define a volume that the CSI driver ultimately manages. And then within our task that actually defines our our application, we can just sort of mount that volume into the application. So in this instance, I'm just using a Docker container with MySQL and then mounting this volume at /srv. For production environments and just general enterprise organizational needs, there's a need to segregate cluster into specific namespaces. Nomad absolutely has that ability to segregate workloads into namespaces, and you can just have ACL policies that give access securely to those specific namespaces. HashiCorp Vault is widely used across different organizations, large organizations, for securing and protecting secrets, and also creating dynamic secrets for applications, i.e. a secret with a short TTL. And we have, there's no surprise that Nomad has a first-class integration with Nomad. So for securely supplying secret information to your applications, and we can do that via a template method. We can template in secrets to be ready to be consumed by the application at runtime. And again, no surprise that if you're unaware of Console, HashiCorp Console, it's a service discovery tool and a service networking tool. It's able to discover services across multiple different platforms, and Nomad absolutely being one of those. So as you deploy a service to Nomad, it can register those services in Console, and then we can have quite intuitive rules around which services can speak to which services, for this concept of intentions. I won't go too far into it, but for the first point is just visibility of services. I can see, I've got service discovery, I can see all of those services and how they're running and how they're networked, and really then there's a journey of start moving towards more service mesh, right? Which is a journey that a lot of organizations are on today. So a bit more about how we're orchestrating non-containers as containers. One of the really unique features of Nomad. Okay. So when I earlier looked at these, pointed out these task drivers. Okay, I used the example of Docker. In this example, we're just using an exec driver. Okay, so what we're able to do is pull down an artifact from a source, and then just actually go and run that artifact. Okay, so that could just be a binary. So what this is the ability to have this single workflow for all of your applications. Okay, the workflow doesn't change whether it's a legacy application that doesn't make no sense to be containerized, or some new cutting edge microservices architecture for a greenfield application. Everything is consistent. And we've just got another example there of using the exec task driver basically. Nodded to this already, but just about consistency in the management of the life cycle of the application is a huge value that our customers are seeing. You're creating a job file. You've got this concept of Nomad job plan. So if you're familiar with Terraform, it's in the same ilk as Terraform plan. Submit that to the Nomad server, and then Nomad goes about placing that job correctly, and then we can have visibility into that job by checking the status and viewing that job. So we've got a nice UI that gives really good visibility into all of the jobs that are running. And again, to reiterate, this is then a single place that we can understand what applications and services we have running, regardless of the cloud provider that they're running on, regardless of the packaging format ultimately. So we have enterprise sort of offering as well with Nomad. I think all of the features that I spoke about so far are available in open source. But then, HashiCorp, we offer support packages around open source and extra features that are really sort of needed by enterprises. And so things like sort of automated upgrade of the cluster. If you're doing Kubernetes on premise, I've heard some horror stories about upgrading. So yeah, this is a really nice way to sort of take the pain out of going through the necessary process of upgrading to the latest versions. Okay, so Nomad does have this concept of sort of non-voting servers. They're ultimately used for read scalability within a cluster. So what we do is we add non-voting servers into the cluster with a higher version. As they're successful and create quorum, then we can remove the older servers. Then we have this concept of automated backups. So we're just taking a snapshot of the state of the Nomad cluster, and then just putting that out to S3 or Google GCS. So yeah, just a nice sort of way of ensuring the ability to recover and restore if necessary. Sort of spoke about this a little bit when I was talking about the automated upgrades, but Nomad provides a way of being a super highly scalable system. So the servers that keep consensus can sort of are voting in that sort of in that consensus algorithm, but then adding these non-voting servers in just ensures sort of higher scalability. And we actually done a challenge called the 1 million container challenge to see if we could orchestrate 1 million containers in as quickly as possible. I think, if I remember correctly, it took about 15 minutes to spin up these 1 million containers. Okay, so highly scalable system and systems in place to do that. And then the idea of sort of redundancy zones as well. So I mentioned earlier about, we deploy, well, especially in open source, you deploy a server in different availability zones. If you lose one of those availability zones and then something else goes wrong and you lose another server in another availability zone, you've lost quorum within the cluster. So we had these non-voting servers in, and if a sort of one of the Nomad sort of leaders or a Nomad server this part of the quorum goes down, and we can promote the non-voting server to to be part of the voting consensus. It's a really nice sort of, I would term it as auto healing capabilities ultimately as well. And this is one of our sort of newest features within Nomad, I would say, and something that's can really improve the utilization of your underlying resources. Okay, so which we call dynamic application sizing. So as a developer, if I'm a developer and I need to go and submit a job to Nomad, yeah, absolutely, I have to define some resources that job needs. Okay. But do I ever know how many resources that job is going to need? And this applies to actual, when we deploy it on a virtual machine as well, right? So I never really have a proper understanding of that until it's in production usually. And as a developer, I'm probably just going to give the maximum amount of resources that is available to me just to ensure that my application works, right? So what dynamic application sizing does is that over time it can look at an application, understand sort of what resources that application is utilizing, and then even make recommendations, or it will make recommendations on right sizing that application and actually, given the option for an operator to actually accept those recommendations as well. Okay, so sort of dynamic application sizing in conjunction with bin packing, is really driving down total cost of ownership of underlying compute resources for Nomad users. And then we talked, I talked a little bit about multi-cluster deployment. Okay, so multi-cluster, the ability to actually join clusters together over different regions is available in open source, but it's just about multi-cluster visibility. So I can see which, I've got a single control plane for visibility, but the actual concept of deploying to those multiple clusters is actually an enterprise feature that we obviously support. And it's a really sort of simple way of, if I've got a job, I've got a job specified, all I need to put in is this multi-region block, and then specify how many instances of each I want in each region, right? And then sort of an update strategy as well. So rather than, I've seen, sort of in Kubernetes, for example, you have to wait the application, and I don't think it's that intuitive. In here, we're just saying, I need 3 instances in region A, 6 instances in region B. And then from an operational perspective, we can add sort of resource quotas. So this can be sort of on a regional basis. So we can limit the amount of resources that are being deployed into a cluster to ensure that we don't oversubscribe that cluster, and then we can also do that to specific namespaces as well. So if we've got a different lines of business, it just ensures that one line of business isn't taking up all of the resources of the whole cluster, and it helps us to sort of plan more accordingly as an operator. Audit login, that is actually enterprise feature, and obviously completely necessary as an enterprise to understand who accessed what and when, and and store those audit logs in case they need to be inspected. There's a question in the chat, so I'll just quickly read through that now. Is it possible to overbook jobs as well? It distributes the available resources. Okay, so there is a feature called sort of memory oversubscription as well, so you can oversubscribe. So that is a feature within Nomad. I think that's not into sort of a solution that you would need. So it's just called memory oversubscription. I think that answers the question. And then we've got sort of, so Nomad has an ACL system, but then it's sort of extended by this concept of Sentinel policies. So Sentinel is available in most of our enterprise products. And it's about sort of policy as code framework that gives those sort of really intuitive and flexible policy language. So you can sort of, deny certain task drivers in certain namespaces, as an example. You could write a rule that says, I only want to, if it's 4 o'clock on a Friday afternoon, we can't deploy to production. So if anyone tries to hit that, we can bring in import the time, and then look at a rule against that time to ensure that we're only deploying sort of in working hours, as an example. So that's all I had on Nomad. There was other things that we could talk about in Nomad, but I wanted to keep it technical but reasonably high level still. So yeah, Nomad makes up part of the what we call our cloud operating model, and is where we look at sort of provisioning, securing, connected, and running applications. And obviously Nomad is in that runtime piece. So I'll open it up. Thank you for listening. I know I talked quite fast through that because I was conscious I had quite a lot of slides to get through, but I'll open it up for questions.
Okay, just give it another minute or so and see if there's any other questions that come in. Okay, not seeing any more pop in here. Thank you for your time and thank you for the presentation. It was very informational. As I said before, we'll go ahead and post this on YouTube once the recording is done. And we hope to see you at the next webinar.
Thanks all for your time. Thanks for listening. Take care.
Thanks.